From Photonics Media, this is All Things Photonics, a podcast where we explore industry-shaping advancements in lasers, optics, imaging, metrology, and sensing. Each episode, we'll speak with some of the brightest minds in industry and research about the trends shaping the landscape of photonics.
Today's episode is brought to you by Hamamatsu Corporation, a leading manufacturer of devices for the generation and measurement of infrared, visible, UV light, and X-rays. Hamamatsu is dedicated to the advancement of photonics through extensive research and offers specialized systems for select applications. Visit hamamatsu.com to learn more.
In the fall of 2020, this podcast commenced its exploration of a burgeoning area of technological progress that now, 4.5 years later, has featured time and again on our airwaves. The technology area was integrated photonics, and at the component level, it was PHIX. The challenge in those days was multifaceted. There was at once a need to understand the notion of photonic integration, as well as to understand its potential to restructure the broader photonics value chain, at least as we knew it. Manufacturing processes quickly became an inroad. To begin to grasp PHIX, it was, and it still is, essential to grasp how manufacturing is central to the so-called semiconductorization of photonics. But manufacturing does not exist in a vacuum. And from our discussions on manufacturing PHIX, additional reaches of the value chain started to reveal themselves. One stood tall at Photonics West this year: packaging. And thus, the impetus for our conversation today with Abdul Rahim, Ecosystem Manager with the European Integrated Photonics Ecosystem PhotonDelta, is born. Packaging is complex, and the necessary process steps that it envelops pose distinct challenges, as Rahim discusses. But in meeting them, designers and fabricators have opportunity to not only advance this facet of integrated photonics, but the aforementioned broader photonics value chain itself. Also in this episode, Carlos Lee, Director General of the European Photonics Industry Consortium, brings us two conversations with major players in the European and global photonics landscape. Recorded at the EPIC Summit on Optimizing and Scaling Photonics Manufacturing in San Francisco, Lee kicked us up with Joost van Kerkhof, COO of PHIX Photonics Assembly, and in a second interview, Michal Nejbauer, CEO of Fluence, the Poland-based laser maker. Those interviews and more up next on All Things Photonics. Abdul Rahim with us on the All Things Photonics podcast. Abdul, thank you for being here. I want to start in an obvious place. Bear with us. Semiconductor packaging, what is it, first of all, and how does that notion apply to PHIX in the photonic space?
Yeah, thank you, Jack, for this opportunity. So in simple words, if I have to say what is packaging in microelectronics packaging, or packaging for photonics is, then I would say that, it all starts from a conceptual phase, from an innovative idea. And normally you could put it on a digital design environment, and then you translate it into a chip. And, and the chip is actually a physical manifestation of your design. And then to make it to make it part of, to make it applicable to our daily life, we have to present it in a form where people can react and interact with it. And packaging is that, more to convert that, chip into a form through packaging where users can interact with it. So I would say that it is one of the most important elements of commoditizing any microelectronic idea or any photonic chip idea. I mean, literally with a chip, there is very little what you can do unless you can package it in a form where you can deploy in a relevant environment. If you cannot do it, I think the whole that innovation cycle, culminates in a less favorable way. So this is how, in a simplistic way, I think photonic packaging or microelectronic chip packaging is.
So very helpful. And a couple of things. You talk about moving value further, extending value so that ultimately you have a solution that has meaning in a real world deployment. The other thing I think that's important to keep in mind is this notion of, and PhotonDelta obviously puts this at the fore, is this end-to-end value chain for the integrated photonics space, for silicon photonics. And so that puts this notion of packaging, it isolates it, but it also puts it in a context where it has meaning, right? A chip by itself is just a chip. In order to move towards solution areas, you have to ultimately you have to do something. So with all that in mind, right, in envisioning this end-to-end value chain for photonic chips, we're now talking about packaging for a reason, right? This was central to many discussions at Photonics West. It will be central to many discussions at OFC and for years to come, I think. At what point did those in the PHIX space and those even adjacent to it begin to recognize that packaging was not just its own technology area, but a crucial one where innovation was its own thing?
So maybe just one little remark that the PhotonDelta, of course, we actually have an end-to-end value chain. I mean, silicon photonics being one form of integrated photonics, but our ecosystem and our supply chain is agnostic to any particular one form of photonic integration. So we work with phosphide PHIX also. We work with silicon nitride PHIX. We work with silicon photonics as well, and more emerging materials, more ferroelectrics or other material like piezoelectronics. So we are very agnostic in terms of material as ecosystem and as supply chain as well. And one of the key elements of our supply chain is, of course, geared towards packaging, where we have and on the packaging side also, we have companies who offer packaging as a service. But we also have companies who offer you equipment, which is necessary to do that packaging. So we have our competencies as ecosystem, both on the service side and on the equipment side. So coming back to your question, when it all started, when the whole mantra of integrated photonics started, I think in the early days it was mostly device level demonstrations. People were happy making one building block, or a combination of building blocks, and at some point of time people were started conceiving some applications with it. And as I mentioned earlier as well, that to have these applications deployed in a real world setting, you have to package them in a form which is reasonable, right? And then people started looking into photonic packaging as well. In the early days, it was more mundane discussions that, okay, in which side should be electrical interconnect, in which side should be optical interconnect, what type of parameters should we be considering, mechanical, thermal. And then, at some point of time, other applications start coming into it. And then the packaging started becoming more complex because you have to integrate other technologies into it. Let's say microfluidics, for example, for certain use cases. People started talking about application development kits and some kind of standardization on for packaging. And then, now in the time in which we are living now, in very recent past, you are hearing about on-board optics and near-package optics and then co-packaged optics. And then now we are at a stage where people are talking about in-package optics, where both electronics and photonics. So this shrinking of photonic and this refinement of photonic packaging is actually enabling photonics and electronics to come together to a level where now people are talking about in-package optics, where electronics or photonics are in the same package, not necessarily in co-packaged form. And I would say that good packaging probably provides, apart from photonic integration as a chip, probably provides the best route to commoditize photonics. I'm not saying that photonics is not a commodity today, but I think for integrated photonics to be commoditized, smart, efficient, cost-effective, and reliable packaging is key. If we cannot do it, I think it is very difficult to commoditize integrated photonics.
So advances in packaging aren't happening in a vacuum, right? They're happening in response to other advances in other areas. And yet the reason we're talking about this is because it's not easy, right? There's a bottleneck somewhere, maybe more than one bottleneck. And I think about different considerations: thermal management, chemical sealing, mechanical device support would be another obvious one. Where in your mind is the bottleneck with packaging right now? Is it one of those examples I tossed out? Is there something deeper that is causing the need for the innovation right now?
So, packaging is a multidisciplinary, as you said, you have hinted at many of the important aspects of packaging. It's a real multidisciplinary topic. And then photonics is sensitive to certain physical phenomena, temperature or stress or influence of the external environment on photonics. It's a very good sensor for that. So I would say that I don't know if I should say one bottleneck, or I would say one issue probably is that on the foundry side, at least within foundry, people have standardized their processes. I'm not saying that the photonic chip manufacturing is standardized. No, there is standardization, at least within a foundry. You go to a foundry, they will offer you a standard process flow. Okay, if you cannot work with that standard process flow, you can little bit maneuver it in discussion with the foundry, and you can add some new features. But on the packaging side, I think it is mostly tailor-made, customized. This is causing a real challenge for the packaging providers as well, because it becomes expensive for them. They have to do custom development for every customer depending on its need, and for some cases it makes sense that you have to customize it if the application is different. But if you have to do customization even for a single market segment, I think this keeps the packaging service provider continuously on the toes. For every customer, they have to do something bespoke or custom. So in a way, it is expensive also. It slows down the process as well. And I think the bigger risk with that is that not many companies can afford this kind of customization. Then this is just my fear I'm sharing here, is that if it remains like that, then there are only few companies who can access it or who can afford it. And then the innovation will not trickle to smaller companies. Rather, we will see some monopolies who can afford it and do it, and maybe then at some point of time they standardize it, and then you take it or you leave it kind of scenario. So I think in a way this maybe standardization is a very big word here, but at least some protocols where at least within industry people agree on lowering the burden of continuous process or development for the packaging providers.
Put this all in a context that welcomes in the idea of AI innovation and big data, right? We're going there. Integrated photonics is going there. That's where some of the innovation is going to be targeted. How does packaging play into all that?
Yeah, I think this whole notion of co-packaged optics is one form of packaging which enables electronics and photonics, to come closer and closer to each other. So this is and in some cases the whole value proposition of foundries is mounted on this notion of co-packaged optics. Okay, in some cases the foundries are not co-packaging electronics and photonics, while they offer more monolithic process flow for electronics and photonics. But in some cases there are foundries which we see today who try to bring electronics and photonics together in a co-packaged form, because at the end of the day, for data center applications or for AI or for optical connectivity for AI engines, let's say between you can call it memory and logic, the connectivity there, then there the parasitics are very important. And if you can, the parasitics coming from the electronic side, and if you can use some smart packaging approaches to circumvent these parasitic limitations influencing the performance of an electronic photonic solution through co-packaging, I think is need of the hour. And and there are developments happening in that direction.
I think about PhotonDelta and the companies in the ecosystem, but then I also think about like a photonic assemblies, right? So you have, it's not parent-child necessarily, but But there are different roadmaps, right? There's a roadmap for the whole industry and the whole ecosystem, and there's a roadmap for individual companies and foundries and fabs. How do you see it from the platform that you have at PhotonDelta packaging? Is it part of a broader roadmap, or is there a separate packaging roadmap that's ultimately going to fold into this broader integrated photonics roadmap?
So as PhotonDelta, so I hope that I have understood your question well. So your question is that is packaging considered as a separate segment for which we are maintaining a roadmap, or is it the integrated photonics roadmap where packaging is considered as one element of that bigger story?
Yeah, that's right. Just that differentiation. How does PhotonDelta see it?
I mean, we really see it from a system perspective. So, of course, the individual excellence which we achieve along all these individual segments of the supply chain is important. But at the end of the day, everything has to go hand in hand. A chip, the chip roadmap, and then the packaging roadmap. If they don't go hand in hand, then the two pieces of the puzzles don't fit together. So to a certain extent, we look more from system point of view that, okay, for the next generation of system, what type of foundry capabilities do we need, and what type of packaging capabilities do we need? And then we try to sync the two capabilities so that we can offer a solution which is meaningful for what the industry needs. But on the other hand, when you look at, so this is more at the ecosystem level. But of course, then in the ecosystem, you have individual companies, and these individual companies can have their own roadmaps. And they're also, our role as an ecosystem organization, or my role as an ecosystem manager, is to bring that alignment. There, the internal roadmaps of individual companies are aligned at the ecosystem level. So what we want to avoid in a nutshell is that having two pieces which don't fit together to offer a solution which is meaningful for our customer. So,
Abdul Rahim with us. Go ahead, Abdul. I'm sorry, I cut you off again.
No, this is fine. That was
all right. Very good. And I want to encourage our listeners to follow you or track you at least on LinkedIn. Very useful insights there. Final question for you, and I'll have you put on your projection cap for this one. OFC happening as of now about a month and a half away. What is the I guess 13-month outlook? So year from now, and then the 5-year outlook on packaging. What can we expect to see in the short term in terms of progress in packaging, and then what can we expect to see in the a little ways down the road?
I think one thing which I am a little bit more comfortable in it is a prediction. It's a difficult business, and everyone has its own crystal ball. So at least this I can obviously see that now we are at a level. In the early phase, it was only foundry, especially specialized foundries who were offering integrated photonics or silicon photonics. But then the microelectronics foundries, large microelectronics foundries, started looking into integrated photonics. There were some specialized design software companies who were offering photonic design, but then large EDA vendors jumped into, photonic design. And now what we are observing is that there was photonic packaging, but now there are large OSATs who are doing microelectronics packaging, that they are diversifying their business, and they are looking into how can we include photonic packaging into our existing offering, and we will see more and more of it. Previously, they were doing it more for, in bilateral mode or dedicated customers or more in a closed setting. I hope that in future, as we expect that this industry will grow and will become, talking from linking it to OFC, the workhorse of the growth led by AI, for example, where the microelectronics industry says that, okay, to reach the mark of $1 trillion, integrated photonics will play a key role. I think with that in mind, these large OSATs will be offering their services to even not only large customers, but maybe prospect, which are today small, but prospectively bigger customers of future. So I will see more and more microelectronics OSATs. They are already moving, but maybe we will see even more thrust from that side. I also think that the cost of packaging is still a big barrier. It will continue to be prioritized in a way where you can make photonic packaging cost effective. This is I think definitely second thing, and I think the third thing is, and there I think it will be a bit of tussle between how the microelectronics world looks at packaging and how the photonics world looks at packaging. People want to have more and more fibers interface to chip, and then the interplay of those fibers or those optical interfaces with the electronics. So it is going to be a quite an interesting discussion that how the photonic and electronic packaging settles in totality. There are a lot of question marks there. So I think we will see evolution in that direction. And lastly, I think for emerging applications. So there also it is still, I would say, relatively early days as compared to more mainstream applications like data center transceivers. But I think it would be interesting to see that how much these new applications can piggyback from the developments of the packaging developments for transceiver applications. So I think that would be interesting to see.
That is Abdul Rahim. You can follow him on LinkedIn. And for one episode only here on the All Things Photonics podcast, Abdul, thank you very much for your time, for your insights, and we will hold you to those predictions, and we'll come back in a year and see that they've all come out. And if they haven't, we know who to blame. Thank you so much.
My pleasure.
Today's episode is brought to you by LightPath Technologies. From concept through prototyping, volume production, and global distribution, LightPath has the optical and infrared imaging knowledge and manufacturing expertise to be your optics and thermal imaging solutions partner every step of the way. Visit lightpath.com to learn more.
Joost, we know each other for a long time, but
We do.
for the viewers, maybe you have to introduce yourself. So what exactly does Things Photonics do?
Yeah, so I'm Joost van Kerkhof, CEO and co-founder of PHIX, and we do manufacturing, assembly and packaging of products based on photonic ICs for other customers.
Is the company new? How long has it been going? How many employees you have? Just to get a bit of a ballpark.
We started in 2018, and we are now, 6 years later, and we are about 58 people, and based in Enschede, the Netherlands. And we just opened a facility in the US.
I think in the US, but also you have expanded, correct? You're growing the companies. You had a new site in Enschede?
That's correct. We started in a incubator facility of the university, where we started with one lab and one office, and that extended. And we recently moved into a brand new facility, what was built for us, with a nice clean room and an office with about 2,000 square meter building.
The reason I wanted to have a short discussion was, we just had the workshop on manufacturing, on scaling production, breaking down the cost, just to help all of that. How do you see the role of PHIX into efficient manufacturing? What role do you play?
Well, I think our business model is contract manufacturing, but we realize that since the maturity level of the whole industry is not really at full-scale manufacturing, that we help customers a lot in the NPI process. And we do see there a need also to both on basically the process, as well as helping customers with engineering. So that's what we offer. So we have a strong, big engineering team helping customers on the product design and the process development.
The most difficult customers are those who do not know the stuff,
Yeah.
Would you say that the customers you're engaging with, how familiar are they with the challenges of packaging, of that manufacturing?
Well, that's a valid point. A lot of customers, they are not experienced, or sometimes they know it rationally, but still they are opportunistic because they would like to basically jump to the result and the conclusions. But we help them, guide them through the step by step, getting them from the idea into the product. But there is a lot of hard work is actually needed to go through all the validation and the testing that needs to be done before you are sure that you have a product that can be reproducibly made in volume.
So in the end, you need a product, and you need the product to be as cheap as possible so they can permeate in many markets. Is it correct that packaging is one of the major costs?
That is correct. It is stated. We always say that it is. It's contained by the definition of packaging. In reality, it's also a lot of bill of material costs. So there are quite some materials needed in packaging. So the added value for us as a company, as PHIX, is the service, is the package, but together with it, it's a material as well. So the real packaging cost as such, I think is not the 80% as is sometimes used, but that's more, I would say maybe 20-30%, but the bill of material in the packaging is significant.
And where do you want to position yourself in terms of high volume, small volume, niche markets? Where do you see PHIX going towards in the future? What are the ambitions of PHIX?
Well, the ambitions of us and where we are now, that's two different things. At the moment, we serve customers with production needs for anything up to like 100,000 units a year. If customers really have potential to grow a lot bigger to millions, we typically work with larger OSATs to transfer the production to those type of facilities.
Okay. Well, I wish you all of the best and good luck, and thank you for contributing to making this industry a cost-efficient and effective manufacturing.
Okay,
thank you very much.
You're welcome.
Thank you. Michal, we're here at this manufacturing summit. Thank you very much for joining us as a participant and as a speaker. I'm not sure everybody knows you, Michal. I mean, I've been to your place, to your old factory. You're with Fluence. What does Fluence do?
We do femtosecond lasers and a fiber technology for industry.
So when did you start? Because it's not such an old company, is it?
Yeah, we started in 2016, and we have already 8 years in this field.
Okay, that's more than I thought. In terms of volume, just since we're talking about scaling up, I don't know if you can say some numbers to give an idea or at least some percentage, but how has the growth been? How many lasers do you manufacture before, now, and in the future?
Well, our capacity currently is about 50 lasers per year.
Yes. So how much do you plan to make in the shorter term, in 2, 3, 5 years? Is it a big growth, a small growth, doubling? How many times more?
Well, the femtosecond laser market is very attractive and grows rapidly. So our idea is to actually accelerate the growth capacity by a factor of 2 for the next year and another factor of 1.5 for the
okay, we're just talking ballpark figures. You know, a lot of our members are about that size. Because how many employees do you have?
50.
You have 50. So typical Epic member. Now, how do you know? Do you have to change something to grow double size, or are you just going to keep doing the same thing and just hire more people, or what did you do to be able to double your growth? Is it on the product design? Is it on increasing the facility? What are you doing to be able to scale up production?
Well, first of all, when we start, we have multiple products, and we decided that we'll focus only on a few of them and make them very mature in terms of production procedures, and in order to build them very fast and high repetitiveness.
Why did you decide to come to this workshop? Is it just because I asked you, or what are you hoping to gain from this workshop?
Well, we're exactly facing this scaling problem right now, and would like to hear the ideas how we can improve. So the volume manufacture is something that is currently happening in the Fluence company.
How did you find the workshop atmosphere in terms of the people exchanging ideas? Did you find it boring, or did you learn anything so far?
No, actually, the format I very liked. The way we're sitting here, the way how we have a panel that was no panel, but rather everybody was speaking. I like it very much.
Okay, so you like the environment where people were talking and exchanging?
Yes.
Did you find that the people were a bit conservative, not opening up, not giving enough information, or were they willing to share enough?
They were willing to share enough. Of course, there's many people very experienced in the photonic industry that you have to face, but this is the great opportunity to introduce, because there's not many people here. So yeah, I like the format.
Okay. Yeah, to be honest with you, I really like how people were really sharing all the discussions, going with the microphones and all of that. I like that very much. So what else are you hoping to experience here at Photonics West? We decided to organize the events here at Photonics West in San Francisco so that we can have an international audience. We had 18 speakers from 11 countries. What else do you expect to experience here at the show?
Well, we have technical talks during the conference. And we meet our customers. We hope to meet new customers and just, show our new release and new products.
Okay, great. So you meet existing customers, potential customers, learn from the conference and all of that. Okay, well, Michal, thank you very much for taking time in this busy week to be with us at this manufacturing summit. And I wish you a great week. Thank you very much.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.